Yeah. So when I saw Lynn's nice little summary of the different languages we've been using and the terms, I thought it. I thought it, and I was aware that lots of people have been doing lots of stuff with this over the last month. I thought it'd be an opportunity for us to share what we've all been doing. I hope you saw the email earlier. So, Lynn, are you prepared to share your screen and talk us through some of the things you've been doing?
Um,
Can I share my screen? Let me see if I
Hmm.
can share my screen. Um,
all my camera stuff just came off. What happened?
okay, I see. Let me get my screen shareable right now, and I see how to do it.
Yeah, it's at the
Uh,
bottom. It's at the bottom of Zoom.
I
It's,
Gary, do you have it
tried to do that.
enabled so other people can share? Yeah, okay.
mm,
I can do it. Let me get on Chrome here.
Len, are you okay?
Yeah,
Visual?
I got it back. I don't know what was wrong. It just clicked off for a minute. I think my Zoom is not up to date. And my little son is not here to teach me how to use the computer.
Little son, he's 30 something now.
Yeah, he's still my little baby though. Yes,
Yeah,
that's true. He is getting a bit older.
I'm just fixing my view here so you guys.
How's your daughter doing? I got to find out. She's near delivery, isn't she?
Almost, she's almost 15 weeks. She's just at the beginning and she's just over getting terribly nauseous. And she's had a terrible lung thing, which is kind of scary. And I mean, but she's doing really well as a person, you know. Um, but, and everything's wonderful, actually. Yeah. Our daughter's pregnant. She's due in October. So, and it's her first grandchild. Yay.
Wow.
Yay.
Yay. Okay, let me see. I can share the screen now. Oh,
Hey, George, we haven't talked in a while, but hello.
Hey, how you doing?
Good, good. Helene, it's good. Hello.
You
Hillary.
must be out in the sun.
Yeah, no, I just gotta be. We haven't had sun in a while. We had some big storms keep coming through. It's kind of interesting.
Well, in contrast, we've been having a lot of good weather. I've been out in the
Oh,
garden every day almost.
what are you doing in the garden? Oh, here we go.
Oh,
Okay.
we're in planting. I just finished prepping all the beds and now we're in planting mode.
Oh, lucky. Nice.
I want to view the whole screen here. Full screen. Are you guys,
yeah,
do you
we can
see the
see.
full screen now
Yeah,
or did you?
yeah, we can
Okay.
see full screen.
Okay. It's kind of small. I don't know what you can see.
No,
I've,
it's okay on
I've
mine.
got it full screen.
Okay, right at the top, it says all three theories. I compared Troncoli, Mobius, bulk, theory of emergence, ontogenesis, and combogenesis. And what I did was took notes on each of them, sent them the notes. George has been super busy. Len didn't reply. George replied, it looks pretty good. Tyler replied with really great, all kinds of notes and all kinds of stuff and clarifying, and that was great. It was harder on Tyler's because it was a whole book. I mean, so I mean, I was afraid because he develops his book quite beautifully. And
There is a Cliff Notes version.
oh, is there? I'll have to look for that. Okay.
Well, now there is. You're doing it.
Oh yeah, me. There
I
you
was
go.
gonna say, George, you're making a little money on the side by writing cliff notes of my book. Is that the?
Now that's an idea.
There you go. Okay, so, and then I want to say right away, Professor Volk, Troncoli, and Mobus, that this isn't a complete table. It needs work. The horizontal relationships don't match. I kind of started it. What I did see was every single one of them had an existing level, and within the level, there's growths and numbers of entities, and there's some variation. Within level opportunities, new combinations, selection, and emergence of a new level. They all do that. That's clear. So on the side, I put them into categories: the level, intra-level, fragmentation, integration, selection, and new level. That runs down the side. Then
I didn't know you could scroll down it. I just accepted the first frame.
oh no, it scrolls down, and like new level, I didn't finish that part, but I did compare your views of evolution and then what I called leaps at first, monumental leaps, you know, and how you describe them in your theory, and compared that. So, because those were kind of some big main ideas.
So let's look at those maybe, the evolution. Go ahead, I don't want to interrupt you, but
When I look at evolution.
the evolution in monumental leaps.
Yeah, okay, it's a good overview. Lynn makes a clear distinction. He thinks in processes and likes to divide his processes into features with clear features and functions, and so that they can be explored and they can be properly studied and tested. So he defines and has a little I made a little chart out of his definitions in the notes. And you have notes. I sent the notes in Google Docs to you. I made a little chart of the difference between, and he very much defines emergence versus evolution. And briefly, emergence is new scales, relative discontinuity, and although there's continuity among the from higher
Scales.
yeah, there's a gap between between each hierarchical level, and it's a meta hierarchy. Where evolution, there's new entities within the scale, relative, like more species, relative continuity, intra-level proliferation, and subspecialization hierarchy. He recognizes in the text, but he doesn't model it in the unbroken sequence as a monumental leap. The monumental leaps, I'll describe what those are in a minute, and definitely, you know, describes them, but it's not part of the chart for the USSO. And with George, ontogenesis is a universal form of evolution. Biological evolution is an elaboration of autoorganization that includes mutation and duplication. And then his monumental leaps are from auto-organization, self-organization, to biological evolution. So it's from pre-life to ancient metabolism / life. So, you know, he sees it starting with more complicated chemical molecules, as does Tyler. Tyler says that it's that there are physical laws until evolutionary dynamics, which are propagation, variation, selection, that began with chemical evolutionary dynamics. And then the modes of evolution themselves evolved. So he has a focus on human evolution as an endpoint in his theory. And from physical laws to biological evolution, where things require imports of nutrients and energy and exports of waste, to cultural evolution, a conscious activity of people, language, tools, symbols, social networks. He calls what do you call those, Tyler?
Well, I dual scale PVS, because there's
Yeah.
a cognitive PVS and a social PVS in human evolution.
And also generally call those 3 levels. Let me see.
The dynamical realms, you mean?
Yeah, thank you. I need to put that in there.
So
he
for
defines
the
these
PBS,
monumental leaps as monumental leaps and puts them in his dynamical realms. So he has 3 leaps because of the structure of his hierarchy. And George has, you know, everybody has the Big Bang leap, but the auto-organization to biological evolution and recognizing a pre-life step. And then Len, I mean, it's throughout his examples throughout his work.
I have a
So,
separate paper on evolution versus emergence or relative to emergence. And I would suggest you change that leftmost box to not versus, which means against, but relation to bioevolution, because that's what I think those boxes describe.
okay.
Well, you don't
Or
have to do that
but
now.
I
instead
have
of versus evolution, just evolution, maybe.
I
Okay.
have a question
Mhm.
to
Go ahead, Helen.
Colleen, yeah.
unmuted. Yeah. I've been reading about macro evolution and micro evolution, mainly when I was looking at language evolution, and it was about evolutionary pressure, etc. And I have the feeling that what you call emergence would be the macro evolution and what is found in the fossils, whereas what you call evolution is the micro evolution, where there's the variety and there's a kind of a parallel set of innovations that are, I mean, like the bottom of your minima in your sinusoid. Does it match, or is it something completely different?
Well, you know, it's tricky when you get into, when you start, I've been doing a little reading about evolution and different theories, and it gets really tricky. And that's where it's important to define, I think, systems processes. And that's where Len has it right. And I'm so accustomed to thinking, after 20 years of thinking in terms of systems processes, that's I really see things, even things, as process. So when I start seeing, okay, when you start reading the Evo Devo people, for example, the evolutionary development, people who see development and evolution as kind of the same processes, they put it together because they're saying, look, in the development of an entity, there's always some diversity. And they're saying it's the same as the evolution of a genus, a species, anything, you know. And they don't go as far as saying the evolution of stars. And it's interesting because in astronomy, they'll say the evolution of stars, when I think they should be maybe saying the development of stars or the self-organization of stars, because those stars up there are kind of repeating themselves and they aren't really evolving as we see. So those distinctions have to be made as a systems, as you look at whole systems. So when I see micro and macro, I question, what are they really looking at? Are they looking at different scalar levels? In which case, you know, are they looking at development or evolution?
They're looking at the shape of the thing. They're seeing macro as reaching a local optimum and a punctuated equilibrium. And they're looking at micro as evolution under selection, pressure, rapid, and parallel. So I think it fits.
Let me break in here as a biologist, and Tyler, you can correct me. I would avoid using the words macro and microevolution. There's a huge debate in biology, and microevolution is stronger and dominant, and macroevolution are, you might call, the outliers, and they're not well accepted by the microevolution people at all. And macroevolution has a hint of emergence, as you're saying there, Helene, but it's kind of not the same thing we're talking about in terms of emergence at all. So I would just avoid incorporating those terms, or at least draw the distinction that we're talking in a different domain here when we're talking about systems and hierarchies. Because macroevolution, even macroevolution, is a jump or a leap in change, but not following the microevolutionary laws of it being on the gene level. It's usually because of bottleneck or something which may have caused the sudden change, what apparently seems to be sudden change in terms of geological terms. So I would leave those specific terminologies to the biologist and not interfere with them, because if you start to bring those in, what happens is they'll just jump on your ass right away. And as it turns out, micro and macroevolution, they're fighting it out amongst themselves right now anyway. And there's certain evidence for macroevolution, but very, very minor compared to the microevolution. Tyler, would you agree with those statements?
Yeah, I do, Len. Yep. That we should avoid getting caught up in that morass, and there is an issue of applying the word evolution, which I'm very interested in. I don't know if we have to go into it today, but whether we want to, I prefer not to apply it to the cosmos, but I do recognize there are sort of I mean, I liked what Lynn said, that the stars, they don't replicate one from the other.
No.
Yeah, they don't evolve, and
the use of the term evolution for stars is
makes me crazy. It makes me crazy every time I read it.
But you can't convince.
Makes the job harder. My job harder.
Let me argue for the use of the word evolution in a more cosmological general sense. The word itself meant change, and it carried with it a sense of directed change. So it's a very general term by itself. What I do is I add adjectives to clarify whether I'm talking about biological evolution or cosmological evolution. And there is a sense in which events that take place in in cosmological evolution are not necessarily replication, but there are generations, right? The stars have gone through multiple generations. The galaxies have formed after multiple attempts to coalesce in clouds and so forth. So I'm hesitant. What I'm trying to do myself is show that this is a very, very general process. What I call auto-organization and selection leading to emergent properties is the most generic or most general process that we can talk about. So that's why I use that term, but I do classify it in terms of social evolution, biological evolution, cosmological evolution, and so forth. And collectively, I call it universal evolution.
Now you're trying to change the word. And,
no, I'm not trying to. This is a definition of the word.
You're suggesting a new, George, you're suggesting a new interpretation of the word evolution. And
I'm not suggesting it. I took it from the dictionary.
Well, I don't give a damn what the dictionary says, because we're biologists and you can't have that term.
Because my other question was, how do you call the whole thing? From
evolution is not change. Evolution is not change, and we're back to Heraclitus.
Okay, let's stop.
That everything is changed.
Hey, this is
I want to step in here and say that.
Whoa, stop.
It is not
I haven't been able to nail down Len on evolution. I haven't been able to nail him down to say, please describe the features and functions of evolution.
Okay.
He has not, I haven't been able to nail him down.
There's the dictionary definition. There's the dictionary definition.
Okay, so
evolution.
This is
any process of formation or growth, development.
Yeah.
A product of such development.
Dictionary definition, and that does not hold for the reams of biologists and the anthill of biologists. They're just going to oppose it.
Well, then I was a biologist.
That's the fact.
I've studied biology, particularly evolutionary biology, Evo-Devo, and the rest. And they always talk about neo-Darwinism or some other qualification that says this is biological evolution. And, you're fighting against a much larger group of people
Yeah.
that take the word evolution to be a general kind of change.
Well, they don't study it and they don't know what they're talking about in terms
You
of
study
biological
biological evolution.
organisms.
That's clear.
Right.
Cosmologists study cosmological
All I
evolution.
said was you're trying to expand the definition, which is okay, because we're talking about systems evolution. We're not talking
There you
about
go. Thank you.
bioevolution.
Thank
Right.
you.
Okay. So,
That's
Tyler,
bottom
you
line.
had your hand up.
Yeah, my hand was up. And so in this paper I sent you all that I've submitted to the big history journal, trying to tie the dynamical realms into some of the other big history theorists, something I recently finished, even though I had started it last summer. I just had to get back to it. I said, I want to send this out. But at the end, I have these things for further discussion, and one of which is the use of the term evolution. because a bunch of the big history people are using cosmic evolution, or I mean, they're using evolution in the George Mobus kind of way, and I I'd like. I want to do some more thinking about it. I don't think we're going to resolve it right now. But I do, and sometimes I think I'm fighting a losing battle, because it's gone so far as a term, Len, that these big thinking people tend to use it. However, if we use it for the whole, like was it somebody was saying, was Helen said, what are we going to use for the whole thing? If we use it for the whole thing, then I would argue, and this we could go into, that biology and culture share something, in which that the physical chemical changes do not share. And I agree with George. There is a kind of a selection of I mean, there's stabilization that happens at all these scales in your ontogenesis, and I mean there's stabilization processes, which you could say is equal to selection in a certain way. But I'm not aware that the success of a certain type of star breeds more of that type of star, which does occur in biology and does occur in culture. So if we were to use the term evolution, like in a cosmic evolution, then I would like to seek another term, which will drive the biologists even more crazy, Len. Another term for biology and culture, because they share this propagation. I mean, what I keep calling the PVS, propagation, variation, and selection, in which things over time that are selected are more prone to continue those patterns. There's a kind of one can judge something like success, or put some kind of metric of kind of reproduce. Well, in biology, it's sort of reproductive success, but in culture, there's also a kind of a pattern success of automobiles that proliferate, or the Clovis points that proliferated in early North America, or language patterns that that proliferate. That the biology and culture, and I don't know, maybe I'll throw this back to George just for a second. If you, George, do you see biology and culture sharing something, and they're different too, but that they share something as a group that physics and chemistry processes would not have?
Well, I agree that it's more obvious that there are things in biological evolution and cultural evolution, your propagation, variation, and selection aspects. But think about this. Stars are not as different as we might think they are. For example, if a star forms with too much mass, it's going to go supernova and have a very short lifetime. No matter, so let me go back a little bit. Every system that comes into existence is going to have a lifetime. Len, you said this yourself. There's no such thing as eternity for any particular system. And so if you put it in that regard, stars that are selected because they were too big or too little will never have planets upon which life could emerge. So in my view, there's one grand process going on, and it transcends across the entire scale. Once quarks came into existence, it transcends across the entire scale, and it has different forms and different details at each of those scales. But nevertheless, it is the process of changing and becoming more complex over time.
And George, that's, just to be clear, that's auto organization and selection. I mean, that would be the description.
That's right. So when a star is forming out of a cloud of hydrogen and helium, when a star is forming, gravitationally, that's the auto-organization taking place. The thing is actually coming together. Now, if it's too much mass, like I say, it has a very short lifetime and may go supernova as a result. If it has too little mass, it dies an early death. It becomes a Saturn or a Saturn Jupiter or a red dwarf or something of that nature.
But then its success of having not too little and not too much does not change the dynamics of the other things that are doing that, because they just do it all independently.
Okay, within this group, we are grand scheme, broad-minded people. And you're forgetting that you're dealing with a bunch of scientists who are very restricted and small-minded people. So in my case, I use the term emergence for that broader thing, not the term evolution, because it's been very much mined and researched by a lot of reductionist scientists. So I use the term emergence where you want to use the term evolution. I think it's very good to use a new term for that and not the old term, because it invites a lot of criticism. Gary, you're running the thing, so your hand went up first before Helene.
What I was going to ask. So what I'd intended to do was to give everybody an opportunity to have sort of 10, 15 minutes to talk about the work that they've been doing recently, because there's a lot of stuff going on. I'm open to letting this conversation continue around this particular table. Clearly there's a huge amount of value in this table, and we need to continue to work together on it. We could do that offline. We could have conversations by email. Do you want to continue doing what we're doing at the moment, or should we bring it to a close, maybe with one or two last questions, and then move on to Len's part? What do people want to do?
I vote for close for this for now. It's a bigger discussion than we're going to continue to have, because it involves. I do think George's ontogenesis and selection and Len's integration and diversification and my combogenesis and other people, my combogenesis with new relations. I mean, we're very similar.
Yeah, I want to make a comment because this is my screen. So,
Okay.
but I want to say that everybody's calling it by their own terms: emergence, ontogenesis now, and combogenesis. And I should put that, that's what it's, instead of calling it evolution. Now, George says that ontogenesis is a universal form of evolution. Basically, I think that's what Tyler says too. Len makes the distinction between emergence and evolution because he's a biologist. And so that's what I see.
But what I don't understand, or what I haven't gotten yet, is whether the emergence of Len is the maximum of the integration point or thing, whereas the evolution is the part in the gap. Or is it not at all at this level that it's that these terms are used?
Kind of described all up in the other boxes. You can, if you go up to the very top and go through it, their theories is kind of roughly broken down.
Yeah, but I know that I understand the theory, but I'd like to know if the emergence is mapped on the integrated maximum of the integration part of the sinusoid process, and the evolution takes part in the in the soup, so to speak, in the gaps. But okay, let's leave the question there.
I'll write you on that, Helene, because since you're referring to that sinusoidal diagram, it has a very specific
okay,
grounding.
that's what I was like intuitively mapping it to, but
yes,
so
it is the integration leap that comes from the diversification. And
okay.
It has a lot of similarities to what George was describing. I'm not uncomfortable at all with there being selection in the physical laws that govern the physical systems emergences. I'm not at all troubled by that. But I've got to say again, this group is a broad-minded group, so you're only getting one picture. And to go on with what Gary was saying, before we even transfer to another 10 minutes, which is already half an hour, we haven't covered even a little micro part of Lynn's stuff. And if we went through all the rest of it, I'm sure we would get in just as heated discussions.
Yeah, so what I'd like to do is I'd like to use this Google Doc to capture our comments and suggestions, offline. So if you could distribute this again, Lynn, and we'll just you can converse by email as well. But I think the value of this is demonstrated. So
include everybody in the emails, even though you're just talking, say, with Helene or something, so that everyone can keep up with the conversation.
Yes. Yeah. So
speaking of emails, I've got a request of everyone. I have two different email addresses. One is my private family, and somehow or another, that email address, which is a Gmail address, got into this discussion stream. And so now I have to transfer, forward all those emails to my work address, which is uw.edu. If you can please make sure when you look at who all the address, when you reply all, switch the George Mobus at gmail.com to gmobus@uw.edu, because this is getting really confusing. I'm losing valuable things. I finally got all of Len's stuff transferred over. So
I'm sorry. I'm so sorry. Could you spell out UW, the extension?
You put it in the chat, George. Put it in the chat.
W.
Put it in your chat, George.
Oh, okay, sure.
Okay. So thanks for that, Lynn. So Len, are you interested and willing to share what you've been doing?
Hit me because I just sent you 16 files and there's so much there that
you got 10 minutes.
You got 10 minutes, Len. Because then I want my 10 minutes, Len. So
well, I'm going to be charitable and just pass it on to you, because I would say the most important two things are first looking at those overview numbers and what they mean, and then second, looking at the one that says caveats and questions or future research questions, because in going through my unbroken sequence of origins, I came up with lots of disagreements with myself. You'll be happy to hear. And I put those in that series of 45 or so small paragraphs, which bring up confusions like, if you're going to say origin of stars, what do you mean? There's population 3, as Mobus was describing, population 2, population 1 stars, there's dwarf stars, there's quasars, there's and so on and so forth. So you can't just say origin of stars. And there's 45 other what you might say bitches that I have with myself about the theory of emergence, which you'll be happy to read over. And there's no use going over those. But the overview screens with the numbers are the reprints I have for each level and the reprints that I have for the isomorphies. And I think that's referring to systems processes theory. And this group really isn't interested in systems processes theory or its spin-offs. They're really interested in the grand sequence. And so I'm just going to pass. Unless you have specific questions.
I think we are interested in the processes.
Well, I definitely am, but I would like to scan. I just got them transferred. I haven't had a chance to even look. Other than I think I opened one file that was just a spreadsheet of papers and whatnot that evidenced various levels. So I would like to know more, but I also would like to sort of take some time and review what you sent.
Yeah,
so maybe we can
I think it
that
really
at
is.
Our next meeting and not bother with it this meeting.
Yeah, I think it really is worth emphasizing, Len, this particular file, which is your caveats and questions from the unbroken sequence of origins.
Yes.
Maybe what I'm thinking is, our collective knowledge and perspectives on the various theories and processes involved in what's going on here. Maybe our collective knowledge can help us to explore and answer some of these questions. Alternative perspectives from all of us on these, I think, would be very interesting and potentially productive. Yeah, so I would recommend that people do take a look at this, and again, I think it would be worth even putting this, into a Google Doc, which we can share. And again, put in some thoughts.
Maybe we could just look at one of them, just so I have a sense of what the kind of logic, logic that Len is putting in terms of what he is asking at each number here. Maybe we could spend a couple of minutes with this, Len, if that'd be okay.
Is there one that you could recommend, Len?
I mean, but just as an example, because presumably, Len, there's a certain logic why these things got numbered the way they are.
Well, no, it's just in going through the reprint files and looking at the articles and the data that more specifically, dividing them up into the files to begin with, I came up with a bunch of
these are specific disciplinary questions. Oh, I see. These are specific disciplinary questions, which we're not going to be, some of us may be able to answer a little bit or not right now, but I see what you're saying. No, yeah, I don't think this is something for right now, because it's not trying to tie these together into the big picture at the moment. It's specifics that are very important. They're the stuff I worried about.
If you look at 5 and 6, for example, let's just look at those two. Which came first, the galaxies or the black holes? The current theory is that the black holes are at the center of all galaxies. Well, did the black hole come first or the galaxy come first? And in response to what you're saying, Tyler, the astronomers don't know yet. There's just not any information on that. They haven't even asked the question which came first. And there's a dynamics problem there. And then I talked about the origin of stars. It's easy to say the origin of stars, but there's binary stars, there's main sequence stars, there's quasars, there's brown dwarfs, there's population 3, 2, and 1. And they came at different times. As George Mobus was saying, the population 3 very massive stars probably happened in the early universe after the Big Bang. And then that spills over to elements. Most of the current consensus is that the elements came from the internal cauldrons of the stars. Well, did they come from the population 3 stars or in the population 1 stars? And that's not clear. And that then overlaps with cosmochemistry. And so
well, Len, now we've got colliding neutron stars, which they now think are the birth of certain kinds of the elements. The new stuff from the gravitational waves is just, and when they focus on that part of the sky, they're finding, I can't remember if it's the rare earths but it now looks like there's a third form of nucleosynthesis, which are the colliding neutron stars.
And that's not the current consensus, but it may become the consensus, just like continental drift became the consensus eventually. So one of the exciting things about this is our comparison across levels may actually lead to perspectives that lead to new hypotheses that the reductionist scientists might use if they would ever read our stuff, which is questionable anyway. So it may be that system science is going to lead to better reductionist science, and right now that's not even anticipated. In fact, it's heretical.
Well,
so I give you
I anticipate it.
Yeah, of course. If you go up just a little bit in the chart that you have there, I suggested the word simultaneity, which is against my unbroken sequence of systems origins, isn't it? Simultaneity would mean that at one point there are several origins happening at the same time at different levels.
Yeah.
And that kind of fights against USSO, but it seems to be more realistic to me.
Yeah.
Well, that's what I was trying to get at in my diagram, is that there were things happening simultaneously and later came together, combogenesis. So in the case of which came first, black holes or stars or galaxies, I'm not sure that that's necessarily a problem.
Yeah.
They could have been happening simultaneously and then got together later.
Yeah, and I think this relates also to the comment that Hillary made in the chat, and also what's been debated a lot in John Kinnaman's group. You know, this idea of middle out creation.
Except in my allometry studies, I find that the current theories go from out to middle. From the macro and the micro
I think,
to us, which is middle.
Yeah, I think that there are several different potentials here, depending on circumstances.
So enough for me. That's too much for me.
No, it's great. Thanks, Len.
I just have a question just to put there, and that I sent by email. Len, you talked about process, and we were, you know, also evoking on Lynn's time about something that occurs and recurs at every, let's say, big leap or big realm. Is there a process that that can be abstracted, that occurs in a
Yes, and that's what that theory of emergence is that she's analyzing. And if you read the paper Metacrescence, it describes it in great detail. It describes how it works.
All right.
It's a very simple process.
Yeah,
like
which is
process,
repeated and applied from the very origin to the...
That's right. So every cycle of ID results in the theory of emergence, or is because of the theory of emergence.
Okay, can you put the link or the name of the paper in the chat?
If you go to lentroncalli.com and go to emergence research under systems research, it's there already.
Okay, so it's called metacrescence.
Metacrescence, yeah.
Okay.
It's concrescence across the levels, really.
Okay.
Concrescence happens at each level, which is concrescence is combogenesis and ontogenesis as a process. They're all looking at processes.
And after you read that paper, Helene, I made notes on it in under Len's notes.
Okay. All right.
On it, it's I have the cliff notes.
You look very comfortable, Lynn. I'm jealous of you. But it is 5:30 there.
Okay. Well, that's great.
Thank you, Gary.
No, thank you, Len. That's added some more complexity to what it is that we're doing. I appreciate that. So who was next? Tom, would you be prepared to explain a little bit about where you are at the moment?
Sure, I'll try.
And then you feel free to do a screen share. You've got 10-15 minutes.
Okay. First, I just want to add a brief story as a addition to my introduction from the last time. When I was in junior high, which would have been in the 1950s, I had a girlfriend, and her parents would not allow her in science class when we talked about evolution. And I think that's the first time I became aware of evolution. And I thought, if this threatens some adults, it must be a good thing to learn. I focused on it and I read on it, and I've spent a good bit of my life reading things related to evolution. So I do use the term evolution, thinking of it in the broader aspect of systems. And I see it as a generalization of the Darwinian evolution, which is what you normally mean if you're a human on Earth talking about evolution. So I see it as a generalization. I see it as a big step forward. I always think of the comment, the quotation, I think it was Dobzhansky. Actually, Tyler uses it in his book about biology only makes sense in the light of evolution. So something bigger, the whole universe only makes sense in the light of system evolution. And that's the way I look at it anyway. But to get to more what I've been doing, we've talked about the types model, system types model that I've put together over a number of years, where I'm trying to integrate the information that many people have come up with about hierarchies of systems, various system types, and also the order of evolution of them, which gets to the combogenesis and the ontogenesis and whatever term you want to use for it. And also there's a possibility of ordering them by complexity using George's complexity measure. We'll have to see how that works out. So I see this as basic empirical knowledge that system science would be built on. And there's a lot of the information out there. It just hasn't been put together completely. Tyler did a shot at it, and Len has done a bunch of it. So I'm trying to integrate that into my types model. In some sense, I see this as the an analogy to the chemical elements. Our elements are system types, and we have information on them. We need to document them and organize them and build everything on top of that. But there's another model. When I first started seriously studying systems, I had separate files for books or for people where I kept notes of what I had read that I didn't want to forget or thought might be useful in the future in writing. And at some point I said, why do I have all this information fragmented? I should be keeping it all together in a single model. So I began to put it into a model. Luckily, I had experience modeling from my work over many years. And I have a powerful modeling tool available, so I was able to use that. And I started putting it together. It's mainly just from my own notes. And I defined a set of classes, which is in effect a schema for a database. I had a person, had a document, which subset of that was a book. I had quotations, I had organizations. And over time, this grew and grew. I now have probably about 20 classes of things. And then the information I kept was as instances of these classes. So I have many instances of a person, probably several hundred at this point. So anytime I came across someone that I didn't know or some document that seemed important that I didn't know, I would put it in my model if it wasn't already there, and just some basic information. At some point, I was then able to start putting these things together, creating relationships between them, and see a bigger picture. And I just saw a lot of potential with this. So I've been doing this for probably more than 10 years at this point, and have a significant amount of information in there. I've discussed it with Peter and Gary, and I did a presentation for them earlier, I guess last week. And they think it would be useful to put up on the website. it's in a modeling tool, but I can automatically convert it to HTML, so any browser can then go through it. Can't change anything, but can see everything. So I've spent the last week or so updating this and trying to transfer it to Gary and Peter so they can review it and see if anything else needs to be done before it's made open to the broader public. So I guess that's sort of put me behind on the work I've been doing on the types. I guess the latest thing I've been doing is looking at lens work and trying to understand how I can integrate that into the type information I already have. I have a bunch of stuff from Len that I think will be helpful in that respect. So Gary, anything else you think I should?
Yeah, is it possible for you to share the system knowledge model? You know, just briefly to give people a taste.
Say it again, please.
Could you share briefly the system knowledge model? You know, on the screen.
Okay, let's see. I think I can do that.
Just to give people a taste of what's coming.
To share screen.
Yeah. It's at the bottom of the Zoom window. If you move your mouse.
Yeah, sometimes you have to move your mouse to get that bottom set of commands.
Okay, I said share screen.
Yep.
But how do I get to the screen that I want to share?
It should then give you a number of options. You click on, if you click on share screen, it will give you a number of different windows.
Right.
Then you click just click on share screen.
Oh, here we go. I think I can click.
That's it.
Okay, this is the screen. Let me see if I can go to something different. Okay, can you see that?
Yep.
Okay, this is the HTML version. And I guess this is my updated one. So these are some of the things that I have in it, some of the types. Collections, concept, courses. The most information is in the people. So
Okay.
these are just the people elements. There's not a whole lot to the people. It's just a full name, their date of birth, their date of death, if appropriate, and a brief description, often just from Wikipedia, and maybe some links. So let me go back here into well, let me go on to people views. People views are diagrams. So let's look at ACOF, for example. Here's ACOF, has a outline, so it sort of stands out a little bit. And here's information about it. Here's books that he's written. Here's someone he's influenced. Here's an organization that he's associated with. Another one. Some of the people that influenced him.
Oh, nothing switched for me. If you switch
Yeah,
screens,
the original screen.
sometimes you have to go to share screen and you have to, I've done this with students. I think I'm on a PowerPoint and it's changing for me and it's not changing for them because I have a couple PowerPoint. Somehow when you do share screen, it's, I don't fully understand what Zoom is doing, but sometimes it shows you several things that you've started during the course of that day.
It selects a window. So if you have several windows open with work on it, you have to switch the screen sharing.
Right.
If you can't change your content within the current window, it doesn't work. If you open a new tab or something, it won't work.
I'm going to stop sharing and then share again. I have a button here to stop sharing. Okay, I've stopped sharing. Now I'll do share screen. Now I get a bunch of boxes. Okay, I think I've got it now.
If you just do it on your screen, yeah. Now
Can you
it's
see it
changing.
now?
Yes.
Okay. All
That's
right, so again,
ACOF.
ACOF's a person. in the middle. He's been influenced by or had colleagues, a number of other interesting people. These are links, the pink things. So
Holy smoke. Oh my gosh.
I can go to Wikipedia. So I don't need to repeat anything in Wikipedia. It's in effect included by reference. So that's one person. So I don't have every person like that, but I have quite a few of them. Let's see, let's start
Yes.
Forrester. Here's Jay Forrester. I think Starman's the one that's taken over for his position at this point. I saw him once, and I looked at his book on business dynamics, but it was $147, so I didn't buy it. But I've collected a lot of information about him. He also worked with Dana Meadows, who's a whole system dynamics infrastructure sort of here. And here's some quotations. Here, I don't know, I haven't tried some of these links, they might be broken. No. So anything that's online, I can link to. So you can find it through a person or through a document or in multiple ways. Once you find it, you can then link to anything associated with it. So we had a meeting this morning showing all the information that's been collected for the ISS. I see that as being things that can be linked to. So if you have other things associated with Forrester, maybe an interview or a lecture or something he's written, you can just link right to it. So the model becomes, in some sense, a directory and helps to pull things together.
And because this is a model, we can create different viewpoints and orderings and things. And you know what we could do, for instance, is we could organize the information related to, for instance, let's say key system concepts or system categories or system types even. Yeah. So depending on your perspective, you can engage with the data in multiple different ways.
I've been very impressed with Akoff's idea of a perfectible system. Not that you can ever get anything perfect, but you can define the process in a way that you can continually improve it. You can get closer and closer to your ideal vision. So I've designed this in a way that it can be easily updated and added. It's extremely adaptable. So nothing's defined more than once. Everything's in the database. Each person is only defined once. I can reference that person in numerous diagrams, but the only definition, it only has one definition. So if the definition changes, all the diagrams change automatically. So even though it's big and complex, it's adaptable.
I'm wondering whether something that I wanted to do for some of the stuff I was working with, but it comes to mind looking what you've done, Tom, is how would it be possible to see how the various Wikipedia pages you link to, how are they intrinsically related via hyperlink, and what does this knowledge, what does this interrelation of knowledge bring? And I'm pretty sure it would bring something pretty interesting in terms of relating different concepts and maybe making synthesis of them.
Well, Wikipedia kind of does that already, doesn't it? So if you go to Roman Catholicism, there's a whole series of linked websites that you can access. Or if you go to the Jewish religion or Hebrewism, it has that as a category, and it has a bunch of.
But it's categories. It doesn't entail. It doesn't. How can I say? Generate a map of interrelated knowledge. I'm not sure exactly, but I'm not sure it does it. What I'm. Well, anyway, that was.
Yeah,
Not like this does.
so One idea that would be very valuable is to go into Wikipedia and edit the links in Wikipedia or put in links back to this. So that if somebody's looking up Eckhoff, for example, and they're just there because they're in Wikipedia, they can come back to this data structure and use it. This is kind of what I describe in what I call the knowledge base, which is fundamentally a network of relations of data that's collected while you're analyzing a system. And the connections are rich. They're incredibly rich. One question I have is, what kinds of tools can we speculate on in terms of doing searches? Because if you're taking a human being and you have to go through click on this and click on that and click on that and so forth, well, that may work for exploratory. But if you have a specific question, who all ever wrote about this particular subject, then it would be nice to have a tool that could go into this network. And network databases do this, but I'm not sure that would be appropriate here. But go into this tool and it would automatically follow links in a search pattern that would lead to elements that would fit into that question. Does that make sense?
Yeah, it does. And I agree. The real value is not from having a list of persons or a list of documents. It's having all these relationships and putting them together. And there's a sort of an infinite number of those that you can do. And I've experimented with various ones, and I see the potential in it, but there's only so much you can do. So I showed you this one as an example. I read a book by Gary Jadagi before I knew who he was, and realized he lived in the next town from me. And I ended up having lunch with him, and I realized he was associated with Eckhoff, who I was already familiar with. And Eckhoff talks about learning from Churchman, and Churchman from Singer. And Singer at Harvard was a student of William James, and was also influenced by Peirce. So here's a whole line of things, and a number of other people. In fact, William Smith, who I think was on the meeting this morning, earlier this morning, is that the same William E. Smith? Gary, do you know?
Yeah, Bill Smith.
Yeah, I think it is. And Ian Mitkoff and other people. So this sort of gives you a better idea of this whole sort of infrastructure. Now, let me show another one like this.
Tom, while you're doing that, can I ask you a question? Do you have a document that's a short document that's how to use my tool?
No, I don't. I have written some things, but I don't have such a document.
Think about it. That might be a good thing to have.
Tom, I'd be curious to what you have in the category called laws and principles. Aha.
All right, these first three should not be in here. I'm not sure some problem with the tool. They're relationships. And again, this is one that got added at some point. I kept coming across these, and I wanted to capture them. So I added to my class model laws and principles, and then I began to capture them.
And I see the one called relationship principle. I'm curious about that. Thermodynamics, yeah, it's all, but the relationship, I'm curious who's saying what here. Okay, that's pretty general. That's pretty general.
Yeah. Yeah, and again, there's more and less in these depending on what they are. Some cases it's just something I capture with the idea to look into it more. So let me show one other one here in fields. This is one that I added later where I wanted to capture related information, similar to what George was just discussing. So here's a biosymmetric semiotics view. At some point I stumbled on biosemiotics, and I got very interested in. I read some of the documents. And I think it's something that's important to us that seems nobody else is too interested in it. So this describes the field. These are a bunch of the people that are involved in it, some of the documents that they wrote. So a lot of the value comes from taking these individual pieces of information and relating them in various ways. And there's a lot of different ways you can do that. Let me show you one other one that's a little different. This is constructivist epistemology. I think the real value would come from doing this on an idea basis. I did some work on history where I showed strands of ideas that came together around 1950 and were crystallized into the systems concept, and then strands that went out from there in various areas based on the concept. And it seems something like that would be really using this to maybe its best advantage.
Right, that's really great, Tom. Thank you so much for this. I can see everyone's excited about it. Like I said, this is going to be on the website in the not too distant future, at least for the ISSS members as a starting point. There's probably going to be we have a regular Saturday session where the ISSS members are presented with a topic, and then there's a discussion. So I suspect that this will appear on there. So yeah, Hillary, please join. goes for all of you. Right, so could we move on? Tyler, could you perhaps tell us a little bit about your book and what you've been doing?
Well, yes, thanks, Gary. So I'll keep this to 10 minutes, but yeah, no. So it's not a new book. What I said I wanted to talk on today.
Okay.
Well, I do have a kind of a new book in mind. I'm tentatively calling it Swimming in a Sea of Patterns. How the universe is patterns, and we're not just in the sea. We have to be active agents, or we have to learn. We learn to swim in the sea of patterns. So I've been sketching out notes for this, but what I wanted mostly to talk about briefly. Well, let me say sort of a big thing I'm interested in discussing, and then I want to get into specifics about lens diversification. And this was triggered by some emails that George and I had about the D side of lens ID, and I want to show how I dealt with D diversification in my book to maybe tie into some of lens stuff, and George will hopefully have something to say. But the issue of what are we talking about when we're using words like integration and diversification, or ontogenesis, or combogenesis, terms that cross scales and are not the same specifics at each scale in terms of what happens, but on the more general level, things being in relation that hook up with those things and stabilize. Everybody in this group is very comfortable with that, but I think we haven't really dealt with the issue of what are we actually talking about regarding this as a common mechanism that repeats throughout these domains or dynamic realms of nature. I think that would be, and it relates to also our discussion about the word evolution, because we touched on this at the same time. So that's a bigger thing I'm really interested in, but specifically I wanted to show you, you're all familiar with lens wave of I and D. I don't need to show that, I assume, of integration and differentiation and diversification. So I was thinking, based upon some discussion George and I had, that I know I dealt with this in my book, and I know how I dealt with it. So I put together a little show for you to show you how I dealt with this issue, that there is a combination and integration you get, but then within the level you can have by diversification. So I want to show you how I dealt with that, and I'm going to share the screen to a PowerPoint that I have used in talks, but I took out parts of it specifically for this book. So do you all see the title of the cover of my book right now? And do you all, oh, it's not progressing. Sorry, I gotta do
I thought you were
the,
going to say, do you all have a copy, Tyler?
um,
Yes, I do.
okay, is it progressing?
Yeah.
Okay,
Yeah.
thank you.
Yes.
So you all know the idea of things combine and they created something on a new level with new relations. And that if I follow this through, I get these 12 levels. And I wasn't trying to deal with, as I texted in a chat today, I don't care. Not that I don't care about the kinds of stars, but it's so problematic to do everything. I just wanted to do the sequence of levels as a nested buildup. Okay, here's how I dealt with lens diversification. It's these diagrams. So these are diagrams from the book, and these are the 12 levels. And you see each one, as I move through it, it's almost the same diagram repeated over and over again. So this would be the ID cycle or ontogenesis cycle. So there's a cyclic nature, and you can do it as a similar diagram. So this is different from lens wave, but it's trying to repeat the same diagram. And the key here, there's two things. One is that the level below, things combine and make the level above. And that repeats in all these. And I try to put the main, I try to classify, even though in the physics, what happens at each level is slightly different, they all involve some kind of energy repose, some sort of new stabilization based upon a regime of stabilization that did not exist at the prior level because more stronger forces were in play that had to stabilize these structures first. Then the key I want to talk about today and just show you is the this little feedback arrow at the top, which is not actually a feedback level. This is lens. I'm going to submit here that in my scheme, this arrow at the top that goes back to the level is lens diversification. So in the quark level, in the fundamental particle level, when the universe is first forming, everything is in such a mishmash that there's interconversions of these things, and this happens now. Even there's interconversions of one type of neutrino to another type of neutrino, or interconversion of quarks to each other. The next one, neutrons and protons, there's interconversion. Neutron by itself in space decays into a proton and some other things. And within stars, protons collide and one gets to become a neutron and makes deuterium. That's interconversion. So this, I'm going to, again, we'd have to get into the specifics, but that this arrow at the top is lens diversification. Here's the atomic nuclei. So from the earliest nuclei within stars or within colliding neutron stars now, whatever, this is the nucleogenesis. Interconversion creates new types. And Len, does this are you nodding at all on this, that this is related to your diversification? Yes.
Yes, I just don't like giving it a different word. Since that word was already established and the mechanisms for it.
You mean diversification? Well, I didn't know your word diversification. So, but I was using interconversion. So I actually like the word diversification. I'm going to admit.
Well, do /interconversion /diversification.
Yeah, well, this is already published. So in a future in my future book, but I just want to show you that I was aware of this and I did incorporate it. And then when you get to molecules are really important because chemical reactions create new because they're so diverse. The interconversions that happen at molecules through chemical reactions, many new types, and leads to chemical evolution, which leads to biology. Now when you get to biology, it's biological evolution creates more types within the level of prokaryotic cell. Biological evolution creates more types within the level of eukaryotic cell. And biological evolution creates more types within the level of multicellular organisms. I want to say one thing about animal social groups. I have here, there are ongoing changes to the animal social group, whether it's a herd or primate group or dolphins, and it's slightly different. I didn't say biological evolution creates new types because I'm aware that animal social groups are not a unit of selection. The group itself does not die or live in the same kind of way that the organisms within inside the group live. But so this is I go into this in the book, but I like to think of biological evolution as having direct death-life impacts on things that can die as a whole. And usually the animal social group does not die as a whole. It can potentially be wiped out by a disease, but you can have an ant colony go decades and decades and decades, much beyond the life of any particular ant colony. You can have a wolf pack go way beyond the life and death of any particular wolves. So I do see here is the animal social groups have the same differentiation, but it's through the evolution of animals inside who are now connected in their sociality. And then we get to cultural tribal meta groups of groups through culture. Cultural evolution creates changes within the level. Agro-villages, cultural evolution creates changes within the level. And geopolitical states, cultural evolution creates changes within the level. So that's basically what I wanted to do today, is to show how I dealt with the diversification issue that I now see correlates to lens focus. And now I haven't gone through in every case of lens and whether so that I think I want to end it at this, Gary.
Well, super. Thank
I
you.
wanted to just make that point.
No, it's beautiful. I really appreciated that. Does anyone have additional comments, questions?
Okay, I'll go back to the little chart and
Mm.
put that in there. I took some notes on it, and thank you.
Mm-hmm.
Yeah, I have a couple. I'll email you a couple of questions about energy repose. But having interconversion equal lens diversification, and actually George's too, is a really simple thing to put into the chart.
And I'm not sure, I think lens term may be better, but George I know has some comments about it too, because I guess interconversion, I was thinking of it's now you know, it's within that level. There are there's complexification within that level, and what that means at different scales. But I like the term. I do like the term diversification. It's probably more meaningful in English.
Hillary, you had your hand up.
Yeah, I was just going to say that there's something running around in my mind about the fact a lot of these evolutionary steps did not just happen once. They've happened many times in different contexts. So that says something about their fundamentality.
Yeah,
like
that was. Go ahead. I'm sorry.
Yeah, you get social groups in lots of different animal species. You get tribal metagroups probably evolved independently in different human organizations, maybe not, but you see some evidence of them in a few animals as well.
Definitely
that
agro-villages.
Below and above.
Yeah. Yeah, no,
So
Hillary brings up a point. Yeah, but although it does look like the eukaryotic cell, I alluded to this, but I didn't make a huge chapter of it. Certain of those steps seem to be more singular than others, Hillary. So the eukaryotic cell, amazingly enough, looks like a singular event, although we don't know whether there were other eukaryote type things, maybe with other archaea and bacteria that went extinct. But I looked at, I didn't know of lens work, but the biologist I interviewed. And so some of those steps may be more difficult than others, like the origin of life, at least on Earth, maybe singular.
The nature of the discussion that Tyler and I had was I got to thinking about this, and thus far, both in Len's model and Tyler's model, it makes it look as if everything had to happen here, and then we get the next level. And then everything had to happen here, and then we get the next level. As opposed to a model in which a few things, a few bits of diversification lead to some combogenesis, but meanwhile, more diversification at that lower level is taking place, which leads to incredibly more options. So I think, Hillary, this is kind of what you're getting at. And I see that as going up the entire level. We still have primitive tribes, primitive in the common sense, living contemporaneously with these nuclear civilizations. So this is one thing I got concerned about. How do we make it clear that everything could be going on at once? Now what we don't see is more origin of life right now.
Well, then George, you're not going to have a eukaryotic cell before you have a prokaryotic cell. And
No,
you're not going to have...
I'm not implying that, but more prokaryotic, more prokaryotic cells emerged to make up, and some of those became mitochondria, and some of them became chloroplasts.
But prokaryotic evolution is still occurring, is what you're saying, George.
Right. No. I'm not saying it's necessary. I just don't want to say that necessarily they are separate.
It is excluded, right? I agree with you.
You know, one way to tackle this is to remember, and I'm going to have to write a paper on this, especially for, there was a really nice paper written by this young Chinese kid about how to look at the development of, human cognition. And it's been seen hierarchically as a ladder. But instead of seeing hierarchies in terms of ladders, see them in terms of networks. And hierarchies develop from networks. And when we see that, it shifts everything. Do you know what I mean? Instead of visualizing the hierarchy as a ladder, we visualize it as networks forming hierarchical levels. Then you move past this difficulty.
Well, yes, it was sort of. I mean, I'm okay with that abstractly, Lynn. I'd have to see the specific examples, but I do want to respond to George. I'm going to have to be shown that I am wrong in the 12 levels that I laid out, because I would argue that the earliest examples at each level were a necessary condition for the subsequent level to form, and not that the prior levels don't continue changing. And Hillary's point that there's multiple emergences of agrovillages is pretty well established in the archaeological literature. However, that required the culture with the metagroup structure in which groups beyond the daily group could be interconnected by language and material things in the hunter-gatherer mode had to precede. So I'm going to say, I'm going to have to push back at what George was saying as just a generalization that it's all like a network that's continually going on simultaneously. I think we can say there are some sequences in which some systems necessarily formed before the next level formed in some cases.
I'm not arguing against that.
Okay.
I'm just saying, after the beginnings of the origin of life, there were other chemical moieties being invented and reinvented, and various other things that would later come into and be incorporated into living systems. So I'm not saying those levels are incorrect, Tyler, in anything.
Okay, so then so then what I'm hearing you possibly say is that we need now a model that's going to incorporate these side ontogenic combogenesis things going on. And that's what I think it's really, I mean, I'm not against it, but it does get really complicated.
It is. Can I share a screen? Oh,
And then Len and Helene want to say something also.
Yeah,
So
just that it could be nested and happening in different, I mean, yeah, it doesn't seem.
That's what Tyler's model is it's nested.
Okay, Len, yeah.
Okay, so I want to make two comments about what you just made. Why does Tyler have 12 levels and Troncali have 80 to 50? And I want to comment on that. In order to get the detail of how one level arose from the other, I think you have to have these intermediate, I don't mean that they're intermediate levels, you have to have these other levels so that you can scientifically propose how one level became the next. So Tyler's is very useful because it constrains the listing from 50 to 12. And that makes it cleaner and easier to accept, but it doesn't show the sequence as well. It doesn't show the reductionism work as well. And that's why I advocate the longer sequence that I have. But it's not in any way disagreeing with Vogt's listing or of 12, because those map completely on the ones that I have. They just shows more detail in my case. And the second thing I forgot by now, but
so Helene then raised, I saw.
Oh, you said you wanted to raise something about diversification.
Oh, I wanted to raise, what do we mean when we talk about these processes that now apply across so many scales? And this is something I really wrestle with. What do we really mean when we're talking about ontogenesis, combogenesis, ID? You know, we kind of know what we mean because we're doing it.
Can I share a screen, Gary?
And then George wanted to share something too. I don't want to
leave. Let's do both George and Helene first, because mine is a document that I was sent to you already, but I'll
George had asked, so let's, if that's okay, Helene, we'll do George's share screen.
This was in response to, okay, this was in response to Lynn's comment about network. And partially, huh?
There's a difficulty with saying Lynn and Len.
Oh,
this is Lynn
L-Y-N-N.
Okay.
And this was the way I was kind of picturing it the whole time, is that there, and you can see there's sort of multiple levels here, but they are, I'm showing connections to them that basically you had a number of things going on in parallel. This is, I think, the diversification. And in particular, you had some combogenesis going on here, and then that gave rise to a new kind of combo, and so on and so forth. But you can see by the structure that I'm advocating that it really is a network of processes going on rather than a linear sort of kind of thing. And from both Troncali's work and from Tyler's work, I think there's a projection, or at least I at first saw it as a projection of a more or less kind of linear process. Now, I agree completely. Certain fundamental things had to be done before the next level could arise, and I think that that's shown in these various diagrams. But
so George, can I just one comment? If you go back to that one that had brains on it, so the one thing that I think we need to think about is, what does it mean when we're mixing scales, when planets come in? You're doing something similar to Troncali, to Len, in a sense that you're trying to distinguish important levels and emergences sometimes are happening, let's say brains are happening within multicellularity and life is happening within a planet. And where I was arguing for 12 levels that were strictly nested, and not that. So somehow we have to figure out what we're meaning here about the mixing of scales versus the keeping of scales. And I'm open to suggestions about this. I think
Well,
it's a
what I
real.
see your work as is, notice these terms on the side. Basically, you could draw a horizontal line through a couple of these and identify that these were the one of your levels, and that some of this now these dotted lines mean I've skipped a lot of details that Lynn may have in there, but basically what I'm trying to say with this is that there are aggregates of this which we can abstract or give an abstract term to and say that this is, in this case, I say sociality, and then hypersociality. And I think, Tyler, this sort of reflects what
You've got everything in there. Yeah, you've got states, agro-villages, the hypersociality. That's what I argue is level 10. I'm not trying to argue here, but just I lay out evidence for level 10, 11, and 12. Genus Homo had occurred before genus Homo sapiens. Primates had, so that's all within animal evolution that took place in groups. So I have everything you've got here, George, but packaged in a different logical way.
That's what I'm saying. That's what I think. These terms here come closer to your levels, whereas I'm trying to demonstrate some internal relations. So this gets back to the notion that Lynn, not Lynn, was talking about network, viewing this as a network of things going on, sometimes simultaneously, sometimes in a progressive fashion, but all of this, and the further up that we go in these things, the more, Gary, I think you made a comment, the further up we go, the more diversification we've got going on. So within each one of these categories, you can see lots of, like Homo sapiens. Geez, we are a diverse species.
Right, but George, I think, gosh, I think it's going to be hard. It's going to be hard to get groups of people to agree on these kinds of diagrams when it's mixing, when it's logically mixing organs within a multicellular body. You know, you've got brains going to sapiens. You're mixing so many levels. You're mixing what I call logical, not ontological levels, but logical. You're mixing levels of logic here.
Yeah, no, I get what you mean, Tyler. I mean, when we do modeling of complex systems in engineering, it's absolutely essential that you don't mix up multiple perspectives in a diagram when you're trying to organize stuff. So, I mean, Hillary will bear me out here. You don't mix when you create a functional breakdown structure. If you start to introduce physical aspects into that, then the diagram can get really messy. Likewise, when you're doing a product breakdown structure, don't try and integrate expressions of function in that product breakdown structure. And I think the same kind of thing needs to be done there. We need to make sure that our conceptual, our logical, and our physical are distinct. And when we do combine those different characteristics in a single diagram, we need to be very careful about how we do it.
Well, I'm open to suggestions. I'm just trying to get at a point, which is that there's more details, and some of those details occur at different. Yeah. What in Tyler's model would be different levels.
Yeah.
And by the way, I mean, my comment on what you just commented is, we're not talking about an engineered product. We're talking about a historical set of facts.
Well, we're trying to make sense of things, aren't we?
Well,
Yeah.
yeah.
And what we're essentially doing is we are engineering essentially a structure for us to understand. You know, we're creating an architecture. I think what leapt out at me when you were discussing this stuff is that okay, so we have a movement from one level to another, and then what came to my mind is that in order sometimes for then to move on to the level above, there has to be some sort of subsystem emergence within a level to add new technologies and new capabilities, so that the next level of complexity can arise. You know, a classic one is, you know, in multicellular life forms, the development of organs, giving a higher level of capability to those multicellular organisms, so they could become, for instance, plants or animals. You know, rather than simply a collective.
And become brains eventually.
Yes. Yes.
Within the organs.
Yeah. Yeah. And you know, in the emergence of our social systems, which is where we're going to come to next, George, you know, the technologies that we are developing within our current social systems, which will allow us to move on to the next level of complexity in the social structure of our planet as a whole. You know, for us
like
to
I
become
said,
ecos.
Like I said, I'm open to suggestions about how to represent this. I
Yeah.
just don't want to lose track of the fact that it's a very complex overall process, a complex history, and there are a lot of things going on, sometimes simultaneously, sometimes in stages. So that's my whole point, and I wanted to address this idea of it being a network of relations and not just a linear track.
Yeah, so I think in these kind of diagrams where you're showing, and you've done it on the side on some of these diagrams, you've shown an annotation of levels.
Yeah, that's an abstraction.
And what you're doing is you're showing in between the emergence of the, let's say, the technologies that have allowed the levels to continually grow and diversify.
Right.
Yeah.
Yeah. So it's basically those are abstractions of you know, general things which can map, I think. I mean, I think I'm quite nicely onto Tyler's.
Yeah, no, I'm not knocking. Don't just misunderstand me. I'm not knocking the diagram. It's just that when we use the diagram, you need to have a certain level of understanding around it, so that you can find your way through, you know, and see distinctiveness.
Well, I tried to do that in the book, so to see if it worked.
No, it's great, and I really do appreciate it. So again, looking at the time, George, would you like to, you know, keep the ball and explain to us, you know, what you're working on at the moment and how that relates to this topic?
Well, I've been on a little bit of a hiatus, other than the discussions I had with Tyler this last month, from Combo, Onto, ID, unbroken sequence of things that are happening. So I haven't really made much progress there. I go back, I did quite a bit of work on the notion of a complexity measure, and I've been trying to do a little bit of application of that and thinking more and more about explaining the actual transitions as in terms of phase transitions. This was a theme picked up by Smith and Morowitz, and they made, I thought, very reasonable explanations of how they look at these things, particularly the origin of life, as not a singular event, but rather as a series of phase transitions. So I'm still kind of contemplating that, and I haven't come to any great conclusions yet, but it may if we look at at various systems taken from each of these levels and try to assess not that we can actually compute it, but assess what the complexity measure of those things are as a means of setting up a, word escapes me, but a metric of, sorry guys, I'm just blanking out. Anyway, so that's, I'm still just cogitating on that. But meanwhile, all of this stuff about future society, which Tyler and I have done a few sessions, Skype sessions, days gone by, talking about where it goes next. I mean, we've got these nation states. There have been sort of some kind of evidence that maybe these nation states are, in some sense, combining. The EU being one, maybe the United States itself is a good example of an early aggregation of states that decided, well, let's just work together, and created a federal government, federation. But on the other hand, in light of all of the major disruptions that we're going to see in the not too distant future, of civilization as we know it, I don't think we're going to see a simple combination process. I think we're going to see a major disruption, a regeneration of new kind of societies, and then maybe we can see some progress toward a more integrated set of, an integrated human social system. So all those other projects that we're talking about, Gary, including redefinition of the ISSS and so on, they're all, to me, there's a lot of convergence. Somebody said something about convergent evolution. There's a lot of convergence that seems to be going on that's been keeping me pretty busy. So that, I don't have any formal presentation. I did want to cover that issue of simultaneity, Lynn's word. So that's about it. Now, Helene, you sent some questions. What, I can't remember right offhand what they were.
Yeah, I kind of tend to, you know, my questions tend to fall like in a river, and I tend to forget what they were the moment after, because yeah, I was talking about possibility of different affordances developed from different ways because of the constraints, but like birds and bats, or so you have an internal subspecialization pre-existing, but you also have how the environment propitious state can, you know, I can imagine that, you know, when the atmosphere or whatever, but that's not very important. Yes, river
Okay.
of complexity.
Well, I'll look for your email and see if I can answer.
Oh, of my questions. Okay.
Yeah.
I already sent an email with my work, but I don't know if
Yeah,
you
no,
got
I
it.
saw that. And,
okay. But that was more on a societal.
yeah, no, I'm talking about for the agenda for today. You had two questions, but right offhand.
Oh, okay. Oh, ontogenesis. Yes, one that. What's your? I mean, ontogenesis. Visibly, you developed it based from ontology, but ontogenesis is an established word in developmental, in biological development, and it means the moment from which an organism is conceived in a life cycle and then dies. I mean, that's what I understood.
The term I'm familiar with in biology is ontogeny. Which is slightly different from ontogenesis. Ontogenesis refers to the origin of things.
Okay, well, whereas I saw it used as ontogenesis as well. That's why I was wondering if there was some confusion.
When I was when I was an undergraduate in university, well, actually, even as a senior in high school and years ago, I was just fascinated with embryology and they're all, you know, kinds of areas around that. And so my reading on, was it Haeckel? Haeckel?
Haeckel, yeah. Haeckel.
Haeckel.
Is
Ernst Haeckel.
ontogeny replicates phylogeny.
Yeah.
Which was
Right,
proved wrong.
but those are two different words. They actually have two different root.
Okay.
But they mean, look, development and sort of evolution might not be all that far apart.
You know what my confusion comes from? I think that in French it's ontogénèse. It's this.
I mean, ontos is a root that's used for a lot of words. Like philosophers have been worrying about ontology for a long time. I think ontology is a bankrupt discipline, but ontogeny.
Oh, thanks. Did you ever read my chapter 2?
Of course.
I would say we are doing ontology.
Yes, we are in a grand sequence.
So here I have ontogenesis as a definition.
Gary wants to say something.
Okay. Never mind this definition. Let's move on.
Well, we can do this in the
Yeah.
paper.
That's why I asked it by email. I didn't intend to discuss this in session.
That's okay. So there's 10 minutes left, and I'd like to perhaps extend that maybe a few more minutes. But there's something I've been working on, you know, building on this, and I'd like to share a few slides with you as well, if that's okay.
As long as I can discuss what has been passed over, diversification, which Tyler wanted to talk about.
Okay, sure.
George.
And can Hillary and myself have 2 minutes?
Yes, that was the idea. Yeah.
Okay, thank you.
Hillary hasn't spoke up much.
We're very small compared to.
Right. Oh.
Hillary's been active on text.
So you remember this, yeah? So we got this was a combination of various different things, but Hillary put this together. So this is a slide from Hillary Soletto. So we got Tyler's grand sequence. We've got the
not quite right, but that's it could be debated because
okay.
The blue should go up to the human tribal metagroups. Animal social groups would be in biological evolution.
Okay. Well, you get the idea, yeah. So these are domains of established science, and system science is something that spans the whole. It looks for patterns across the whole.
Yep, it's good.
We've talked about this we've seen this slide before as well. But where I'm going with this is, remember in these slides, I also, you know, here's combogenesis going from agrovillages to political states. So I reused your format, Tyler. You know, here we've got the combination of animals, plants, and cultural metagroups into agrovillages, and then using the four quadrant means of analysis from Hillary. So we've got members are constrained, members get benefits, new types of systemic properties, and new types of affordances for new relationships, in this case, crops. And then agrovillages came together to form geopolitical states where the emergent property was command and control. Laws and customs are the constraints on the agrovillages. Hopes and securities, the benefits for the agrovillages, and affordance for new relationships, wars and peace. But I added to this the development of technologies, and you know, these technologies are enablers for I don't know, greater levels of complexity at the higher level. And here we've got water mills, blacksmiths, and grain stores, for instance, as ancient technologies, which then led to, you know, perhaps a greater level of I don't know, complexity of agrovillages. You know, agrovillages have evolved with the additions of new technologies. Geopolitical states evolved with the emergence of new technologies like cities and infrastructure, currency and industry, and many others. There's a great game called Civilization 6 where you can see the different levels of complexity, if you like, that emerged in these different eras based on the technologies that developed. And what we're pondering at the moment is where we are with our current global human social system. Unsustainable growth, climate change, mass extinction, pollution, and toxins is the overarching feature for this at this current time. And if we look at agro-villages and the state of agro-villages currently, we've got monocultures, we've got fragility, poverty for the many, unfair trade, and then at the geopolitical state level, you've got uncontrolled growth, dependencies, convenience, which is offered to the participants, and debt and profit for new relationships. And in terms of the subsystems, we've got megacities, multinational corporations, the 1%, the global economy, and at this level, we've got social media, on-demand consumption, Internet of Things, and big data. And what does this offer up for the future? Because this is not sustainable. Something is going to have to give. So, I'm wondering, if we were to reimagine the future with permaculture, regenerative roots, resiliency, sustainable cooperation, life values, meaningful purpose, accountabilities, mutual dependencies, and different technologies here, as suggested by George in his current chapter 15 as he's developing it. And then what about ecos? What comes next? What kind of technologies do we need to introduce at a geopolitical state level, and at potentially this higher level? So hopefully, and the reason why I'm showing this is because I'm trying to explain that the stuff that we've been doing is actually potentially really practical and useful for thinking about the future of life on this planet.
That's really interesting, Gary. It's a hope of mine to that this work what you're doing is trying to kind of subframe aspects and use it to see where problems lie, and then see where possible solutions, types of problems and types of solutions.
Yes.
Both technological and social. Yeah, that's really interesting.
And I think it builds on all of the concepts that we've been talking about for the last couple of hours, I think
that's where it connects with John Kinnaman's four quadrants. And I was thinking about how do these, how can you look at these in terms of causes, different causes, and also in terms of information, but that's another topic.
Can I break in?
Sure, please.
When I look at this and I consider, what I'm working on too, I think back to Bela Banathy, who 20 years ago was my very first introduction to systems and system science. And he was saying that culturally we're evolving, that humans are evolving to consciously design systems instead of just, adapting and and traditional systems and adapting them and changing them, that we're moving to consciously design systems. And in order to understand how to design a system well, you have to understand the processes that make up systems. You know what I mean? If you understand, like Len has been saying for a very long time, if we can understand how successful systems have been created in nature throughout time, then we can better tackle and design systems for our own lives. And right now we're designing marriages, families, everything from scratch. People don't even know that they're doing that, but it's being required. Your workspace, everything has to be designed in a different kind of way and thoughtfully. I think that it's showing up that, and the United States is a design system that was consciously designed in advance. You know what I mean? The Constitution. And now we need to redesign how we're working together because it's become more complex. So I think, first of all, this is beautiful. These charts are fabulous. I think what we're moving, the big step that we're moving to is a consciously designed systems, all the way up from our relationships, all the way up through our marriages, our families, our communities, and then globally. And I believe now that ethics are going to be the driving force, and ethics are simply can be measured, and they are flows of information, matter, energy toward the health and well-being of the systems around me, and ethical systems. So we can globally describe ethics. We can globally describe processes that will work or not. And we can look to the kids who are forming societies right now online and as networks and in different kinds of ways. It's very interesting.
Thanks, Lynn.
The chapter 14 that I'm working on, struggling with right now, introduces the notion of what I've been calling intentional evolution or intentional things, which is and that was one of the major transitions I think that happened in human consciousness. So I'll have to follow up on Bella's work. Maybe you can supply a suggested reading. I was not aware. I mean, the idea has been broadly expressed by a number of philosophers. So that's not a new idea. I just wanted to pin it down to human cognition and how it is not that different from a traditional notion of chance and necessity in evolution, but rather it's intention with a little bit of chance and intention based on necessity and so on and so forth. So anyway, yeah, that's great.
Okay. Thank you. So I'm going to start wrapping this up now, and the way I suggest we do it is we give Helene first 5 minutes. If you want to share anything else, or you just want to remark or raise topics of discussion, but just 5 minutes, and then move on to Hilary for 5 minutes, and then for the rest of us just to have a couple of minutes for final reflections before we end, and start to prepare for our next session in a month's time. So Helene?
Yeah, I'll just show what I've been working on that some of you already know, but some don't. So Tom, you were talking about biosemiotics, and I've been focusing on, is my unmuted? I've been focusing on the patterning, languaging aspects. So trying to show how language is something that came on top of something that already existed in the living world, that I decided to call patterning, and well, maybe it's already been called this name, and looking at semiosis as a fundamental process for evolution, which is not the Saussurean semiotics of, structuralists that look at discourse and what words signify and what's the signified and the signifier, but rather on a molecular or cell basis or organism basis, how events generate or detected or are detected by signals, and organisms detect these signals. Sorry, I'm not very articulate, and produce a response, a sensory motor response. And so, and looking onto what Maturana called cognition as the capacity to operate in an environment. So a broad definition of cognition, that a bacteria has cognition as long as it can operate in an environment. And so, well, the interesting thing is that Hofmeier, the biosemiotician, has mapped some evolution of semiotic competence to the evolutionary tree, and showed that actually, or provided the conjecture that the expansion of semiotic competence and capability by seizing new possibilities for sign interpretation, basically through acceptation or new affordances that could be generated in this diversification. I mean, this is my interpretation of it, how I map it onto your work, in the diversification phases. So these sets of micro evolutions basically lead to greater leaps, which are not meta leaps like the ones you describe, but that are leaps within the speciation realm, that generate new competencies or cognitive competencies at the species level. And because this occurs in operational closures, in niche environments, you have this diversity of, within a specific species, of modes of operation with some variations. So I suppose that in great apes, orangutans don't behave exactly the same way as gorillas do, or some birds have different practices or ways of doing things or behaving that others don't. And humans speak different languages, have different forms of syntaxes or different ways of representing things through language, even if they share the capacity for language. So I'm looking at, actually, and I'm looking at this process, or this system process, that where cognition, where leaps, where increases in cognitive competencies enhance the sign systems that organisms operate with, and which enable more complex interaction. And you have a recursion here that evolves, or that creates the complexification of the signaling system. But this, so it looks like a linear evolution, but of course in here a linear progression, but of course here you can have different levels and nested processes. So this is what I've been working on, and what I'd like to do actually is to see if this, what's the equivalence of cognition at the inanimate level? What's the equivalent of communication system at the inanimate level in all these realms, physico-chemical realms? What's a niche interaction, or what's an operation at the inanimate level, to see if similar processes can apply. And the other thing that I wanted to create a slide for is the 4 quadrants, and seeing how this can be translated in the form of these 4 quadrants in terms of information. And the last thing is, after a discussion with Tyler on alpha kits, is to see if there's a way to say, well, you have a big, large alpha kit on, say, human language, but then you have instances of languages that are different because of the variety in human cultures and languages, but they still connect to the main capability of human languaging. So I didn't get into the detail of patterning here, but yeah, that's what I wanted to show and say, probably too fast, but that's it.
No, that was great. Again, I can see, lots of relationships with what we've been discussing so far on this discussion.
Yeah, so it was just for everyone to know, so to get a better conversation next time.
Hilary, do you have some things to share, reflections?
Not very much. I've just been trying to keep my AirPods alive as they're running out of power. I've been putting one at a time into the charger. No, I think that has been a really constructive meeting, and I mean, it seems to me that I think we're beginning to understand each other better. So the dynamic seems to be better and more constructive. So thank everyone very much. I mean, I've just been listening. It's been really, really good. And I think Lynn's starting to map the ideas and getting that discussion going. I think that's going to make get us quite quickly to, I suppose, the first step of actually saying, these are they're either three people saying the same thing or they are complementary, and actually putting them together, we can get, whether we merely get better ways of explaining to different audiences the same thing, or whether we actually get an integration of a picture that is more complex than any of the starting ones. Either would be good. So yeah, I'm very pleased to have been able to play a small part in helping this to happen, and listen as it develops. That's where I am at the moment.
Okay,
I mean,
thanks,
this
Hilary.
is combogenesis in action.
It is,
Absolutely.
yes.
Of a new culture. I mean,
There was a previous diversification, and now.
Yeah. Yes. Exactly.
Yeah.
Exactly. That diagram is in my book. Is in my book. In fact, I mean, I think the more important point is coming back to what Gary was saying. I guess 3 months ago we thought we maybe had 10 or 20 years to discuss it. Now it's clear we've got about 20 days, because the one thing we can be sure is having put such a big perturbation into the world's financial and economic and social system, because that is a complex system, it cannot reset to its previous state. So there's now an opportunity to hugely accelerate, either in good directions or bad directions. And if governments are going to spend huge amounts of money on Keynesian stimulus, then they either spend it on trying to restore the old order, which I think is broken beyond repair, or on Green New Deal and tackle the important and not yet solved problems that George is pointing out to us.
Yeah, agreed.
So,
we've got an opportunity at the moment. We can't miss it. Okay, so let's go back through the order that things were presented. So Lynn, could we come back to you and your thoughts at the moment, so we can wrap up?
Well, I'm pretty excited. First of all, I've got, I see where Tyler's coming from thinking-wise right now, and where George is thinking right now. And of course, I know where Lynn's coming from, working on his book. And it's pretty exciting, actually. I'm really looking forward to talking to George about Morowitz and the phrase transitions. I was just literally writing about phase transitions this week and state transitions in my field guide. I want to know about his ideas about the complexity measure. I want to compare that to Lynn's. Lynn describes scale changes in these levels. that are very important. I want to see what this complexity measure is and how we can put that together with scale.
Ryan Rasmussen.
So, and then the future society things, you know, that's just like too much fun. Also, George brought up convergent evolution. I want to look up Corning synergy. So I have tons of work to do out of this. And I want to talk to Tyler too about processes. I want to have a conversation there. So that's mine.
Great. Thanks, Len. So Len.
Oh, and Helene, I forgot.
Okay.
It's really, some really good things came out of what you just described. And I have some thoughts about that too. I took some notes. So I'll be getting back to you. Okay.
Super. Thanks, Len. Len, did you have some thoughts for us?
Two items. First of all, on chat, there's like 75 items. Can you capture those and send them to us? Because I didn't get anything last time on the chat.
Oh, right. Okay. Yeah, I'll send you.
So there's a way to make that into text and send it.
There is. Yes, I can do that.
Do it for the last two meetings then, if you can.
Yes, I can.
Okay, good.
Len, sorry, Len, if you open the chat box, bottom right-hand corner of it, there's 3 dots in a wee rounded rectangle. If you click on that, it will let you save your own copy of the chat.
It says save chat. Okay, and it'll appear on my desktop. Okay, I still would ask Gary to do that for all of us, though.
I will. I'll do it.
Okay, thank you. And the second thing is, I was going to put on the screen the answer to the question about diversification that both Tyler and George Mobus and Hillary are interested in. It's called Genetic Case Studies of TOE CS versus PIS, which sounds like piss, but it isn't. It's TOE case studies versus peripheral instabilities. And it goes over 15 main headings, 33 subheadings, and 105 sub-subheadings, which are the details. It has about approximately 50 central stability mechanisms across the 15 levels, which I can do off the top of my head because they're in genetics, and approximately 50 on peripheral instability or variation inducing or causing mechanisms. And that's what you guys asked about, is the bottom of the sinusoidal wave of many levels, like 50 some levels or so. Diversification, you weren't convinced or understood how diversification could happen. And that details how the diversification arises out of the central stability for each level. And I would ask you to look at that. I'm not going to put it on the screen right now. So genetic study of TOE, CS, VS, PIS, I already sent to you. And if you can't find it, ask me to send it to you again. And that's a very detailed quickie for the genetic case studies, which go from molecular to ecosystematic. Okay?
Yeah, you could link it in the chat perhaps as well, Len, if you would.
I don't know how to do that.
Well, if you go onto the web page, copy the link and then put it into
well, I've actually sent it to you already, but I guess I'll send it to the whole group again. Okay. Please, and then if you have any comments on this 15 files I sent you, which Hillary are very detailed in terms of the isomorphies, about 7 to 9 isomorphies across the various levels of science. I think that's exactly what you asked for.
Mm.
And Len, which paper is that again? That gets down to a number that I can wrap my head on. Not that it's not bigger than that, but the 7 to 9 isomorphies. I'd like to study those. Which is that one of the papers you just sent out to us?
Yes, there's a summary chart that shows how many papers I have for each discipline, for each isomorphy. That's one. And then the other thing is the actual Excel files with the references in them.
I'm mostly interested in what your 7 to 9 main isomorphies are, not all your hypothetical ones.
I have no hypothetical ones.
They're
all hypothetical in the sense that I do not say for sure that there's 100 isomorphies. I say we're studying 100.
Right, but you've got the 7 to 9 that you are feeling most confident about.
Yes, that's right.
Yeah.
Which paper is that of the ones you just sent out?
It's the first attached file, and one of them, it's called, what is it called? Overview of numbers of reprints per isomorphy, or ISP.
My head starts going a little blurry though.
Right. Len, is it also the 7 Excel spreadsheets you sent out? Chaos, cycle,
Yes,
feedback,
those
flow,
are the
storage,
specific,
hierarchy,
though.
symmetry, networks, synergy.
Yeah, the table shows just the numbers of reprints I have for each one. So it's an easy overview of the everything. And that's why it's called overview. And then those Excel spreadsheets are the actual titles. What you might want to do is ignore all the references and what journals they come from. Just go to the titles and read across the titles.
Yeah.
Okay.
And write me, Tyler, if you are
okay
for more. Okay.
Okay.
I'm done. Thank you.
Thanks, Len. Tom. Any thoughts?
I want to take back what I said about nobody looking into biosemiotics, because obviously it reminds me of a quotation I have on the one diagram that I had up earlier from Hofmeier, that, quote, the sign rather than the molecule is a basic unit for studying life. So the biosemiotic people definitely look at the world in a different way. And I don't quite understand this, but there's probably something for us to learn from it. So it's been on my list for years of things to look into more. This has been great discussion. I've learned a lot from listening to everyone. I really enjoy it. But my vision is that at some point we'll have a working model that we all agree on of at least the basics of system types. And we have names and definitions that are the basis of our ongoing discussion. Doesn't mean everyone believes exactly the same thing. There certainly can be questions and issues, and there can be multiple views on things. But at least we captured it and integrated it and have a working picture to go forward with. That's all I had to say.
Thanks, Tom. Who was next? I think it was Tyler.
Okay, not really much to say. Great discussion. I want to say I'm really glad that Len is now like in this. I mean, he was always in there, but sometimes in the earliest ones had other things to do. I'm really glad you're in this, Len, and Helen and Lynn. I think you're both making fantastic contributions to this group. So I want to say I'm really happy about that, about your participation.
Thanks, Tyler. George?
What Tyler said.
Yes.
Only to say I'm extremely excited about where this is going. When I read Tyler's book initially, I said, "Holy mackerel!" Yeah, and we have a highly overlapping bibliography, so it was clear there's something going on here. And then when we discovered Len's unbroken sequence, it was absolutely clear that we had to do this.
Yeah. So yeah, I echo what George and Tyler said about this being a great conversation, and thank you everybody for this. I think what Lynn has been doing, collating the different perspectives on this common theme is really valuable, and we can use that as a way of continuing the conversation between the meetings, and we can start to populate some of the other aspects in there. I mean, Lynn, would you be able to perhaps take Tyler's drawings and maybe start to annotate those within the document as well?
Yeah, each of them have models that are just that really describe things.
Yeah.
How they add to each other is really an interesting thing. And by the way, it's extremely important for me because I'm trying to write this book, and I'm trying to describe different systems processes, and to put this. But I'm not trying to be the be all and end all. And I'm trying to say, this is where we're at with this, or a way to look at it now. And forgive me for, I'm a science writer. I'm not a, it's interesting. So thank you, thank you, thank you.
And Tom's model, which we're going to be putting onto the ISSS, we can start to integrate this work into that as well. There's also a place there for all of the information that Len has been generating for the last, I don't know, 60 years or so. So it's great.
If anyone will look at it.
Well,
I can interpret it.
We are, Len, we are.
Yeah, definitely.
Sorry.
Yeah, the other thing which is still at the back of my mind is that the work that we're starting to collate in Lynn's Google Doc. At some point, we must use that in a paper, a joint paper. I think that would be a big plus for system science. Right, so thank you all. I'm absolutely exhausted now.
Did you get comments from Helene and Hillary?
Yeah, they.
Okay.
Unless you want to have one more turn, but I think we're done.
No. I do want to ask Tom if he is. Are you still doing any kind of software development work?
No, I'm not.
Okay, let me just throw out an idea. Maybe this would become under the auspices of the ISSS. We need a bunch of software tools to make all of that information accessible. I've got some ideas about what those tools would look like, but it's going to take a team. Maybe, yeah. I imagine. Maybe the ISSS could start a nonprofit development group, and let's have at it. And putting those in the website so that people could formulate questions. It's just like any query in any kind of database situation. Anyway, that's all.
Interesting idea.
Yeah, Tom will fix it. Okay.
I wrote all the good I thought about this conversation in the chat. Zip.
Great. Okay, thank you. Okay, everybody, enjoy the rest of your weekend and take care. Be safe.
Bye-bye.
Thanks.
Bye.
Thanks, Gary,
Bye.
for setting us up. Thanks, everybody. Thanks.
Thank you.
Thank you.